Now we're recording. Okay, so today we are continuing with the derivative. Today is the 14th of May 2013, but it's not, it's the 15th actually. I messed it up in one YouTube video and they mentioned it in the comments. Thank you, Danny. Okay, we're picking up yesterday from the derivative, and when you watch the videos from yesterday, you're going to see that we talked about the slope of a tangent line. So, super quick review. And we talked about two different things yesterday. One, if you cut across a function, you create a secant line. Latin for sever, because you're cutting across. It's like a shortcut. If you barely touch a function, and we talk about that line, that one is a tangent line. And we spent a lot of time yesterday talking about how it's not that hard to find the slope between 2 points. We've been doing that on and off since Algebra 1, but it is kind of difficult to find the slope of a tangent line. And the formula we came up with was, for finding the slope of a tangent line, we said f prime of x equals the limit, Diego's favorite, as delta x approaches 0, f of f plus delta x minus f of x over delta x. Remy and Danny, does that look familiar?
Yeah.
Okay, everyone else, this will look new, weird, and a combination of everything else we've done. All right, Nate, you getting this?
Yeah, I'm
Okay, trying to
drawing
run
that
that.
line.
Okay. All right. Now this, don't let this freak you out too much. This is just some y value minus some other y value over some x value minus some other x value. Okay. Now there is
Wait, y1, right?
y1. Thank you, Remy. Excellent. Excellent. Now there is a general pattern to this thing. There are general patterns to this. Here's what happens. This formula will always, always, always let you find the slope of a tangent line to any function you can imagine. Okay? But there are patterns and shortcuts depending on what type of patterns, what type of functions we're talking about. And the first shortcut is when you're looking at, I'm going to say not even polynomials. I'm going to say monomials. What's a monomial?
Monomial with one.
I get what you're trying to say, Diego, but can anyone say it a little bit more precisely? A monomial is a type of polynomial. It is a type of function, true. It's a polynomial. How many terms does it have?
One.
One term.
That's what I was trying to say. Couldn't think of one term.
All right. A one-term monomial. Very simple example of that would be if we were looking at y equals x squared. I'll go through this a little bit quickly. Remy and Danny should be able to keep up. If I want to find a formula, an f prime formula for telling me the slopes of tangent lines that barely touch a parabola, okay? That barely touch a parabola. I've got to plug that into that. So f of x is x squared, so f of x plus delta x is just x plus delta x squared. Anytime you have f of anything, you just plug it in. Replace the x with whatever is new to the function. So now this looks like our f prime of x, our formula for finding the slopes of tangent lines, is the limit as delta x approaches 0 of x plus delta x squared minus x squared over delta x. Okay? I just took my f of x plus delta x, plug that in, my f of x, put in the function I'm talking about, and now I have a formula. This looks easy to solve, right? Actually, Danny, right, this is a lot easier than what we did yesterday.
Yeah.
The one yesterday was much harder. This is a new type of limit, guys, like I said before. We talked about limits when x was headed somewhere. But this is a limit as an x interval shrinks. That's new and different. What we're doing is,
Can the x interval get close to infinity?
yes, but I'm not really sure what that would describe, because we're talking about the actual, it's an interesting question. We're talking about the actual distance between 2 points.
Right.
Okay, what happens is these get very, very close together. If they're far apart, we can find a slope of a secant line, a line that takes a shortcut across our function. If they're close enough together, infinitely close together ideally, we can find the slope of a tangent line, an instantaneous rate of change instead of an average. Now, you guys, they saw how this works yesterday, so I'm not teaching this part from scratch, but I'll repeat this one part. A limit is like a dog on a leash, okay? If I let the dog off the leash too soon, it doesn't work. Right now, the thing to avoid is 0 over 0 at all costs. If I let delta x just reach 0, if I let this dog off the leash, that's 0. So I get x squared minus x squared, which is 0, over delta x, which is also 0.
0 over 0.
0 over 0, and that's that indeterminate form that we said cannot happen. We reviewed that yesterday as well. This is not allowed. Never, never, never allowed. Can't happen. So there must be something else we can do. And take a look at the other board. Diego's not in the way. That'll work. Okay. So let's see what we can do here. The goal is to manipulate the algebra until we actually have something where we can let delta x equal 0. Let that dog off the leash, and we'll be okay. This will go faster than yesterday. I'm going to FOIL this. I cannot distribute the squared, their terms, so we're going to get x squared plus 2 times delta x times x plus delta x squared minus x squared on the top over delta x. All I did was expand this binomial.
The x squares will cancel out, right?
Very good. Oops, I forgot something. I forgot something I have to write and then I take off for if you don't write on a test.
The limit part?
The limit part, yeah. I haven't let that dog off the leash yet. I have not performed the operation, so I have to keep writing the operator each and every step. But now, like Diego said, the x squareds cancel out. And I have the limit as delta x approaches 0 of 2 delta x times x plus delta x squared over delta x. Is it okay to let delta x equal 0 yet? What will happen? Like dodge that 0 divided by 0 problem. If I let it equal 0, what do I get?
You get 0 times x.
2 times 0 plus 0 squared over 0.
Nothing.
Can't dodge a problem yet. Remy, you figured out how to fix this problem yesterday. You remember what you did?
Yeah.
What do we do?
We did what we did with the other.
Yep.
Yeah.
What did we remember what that was specifically? How we got rid of the delta
Oh,
x?
yeah, 1 over delta x time.
Oh, that would work. We phrased it differently yesterday. That would work, though. I see where you're going with that. What you said yesterday was we could factor a delta x out of every term on the top.
Oh, yeah.
All right? I like your 1 over delta x idea, though. That would work also. So I factor a delta x out of both terms on the top, and I get 2 times x plus delta x over delta x. Now, someone other than Remy, now that we factored those two out, what can we do?
Well, you get 0 over 0, 2x plus 0. Those will
Well, you
cancel
can cancel these
yeah.
out,
Then you get,
because they're not 0 yet.
right, so you would get 2x. If you let the dog off the leash, you get 2x.
Boom, yeah. Now, dog off the leash, no problem. We get 2x. We've solved this problem. You gotta algebraically manipulate things so that you can release the limit and not get 0 over 0.
Where did delta x go?
They canceled out here.
No, but the other one.
We let it reach 0.
Oh.
You can let the limit go to where it's headed anytime you want.
Can you stop the limit before it gets where it wants to get? Like,
You're thinking too much like physics, like it's a process.
yeah.
But wouldn't that still be wrong?
Because the limit,
No, it's-
because in order
Stop.
to get,
Hold on a sec. You let me ask Diego's question first. Whatever you're talking, once you describe something in terms of a limit, it is headed there. It's going there. It's headed in that direction.
right.
You don't really care if it arrives or when it arrives, and that's what gives you some latitude to play with it.
But
It's a very informal way to talk about
if
it.
it's gonna get, if the limit wants to get to 0, it has to pass through like 1 or -1 at some point, right? So can you just say the limit equals -1 also? Can you
No.
let the dog off the leash when the limit is at 1,
Yeah.
heading to 0?
Nope. The dog is going to head to here no matter what. Like it's a steak or a bone. It's
So
going to
you
get
can't,
there.
alright, so you can't stop it.
You can't stop it.
Alright,
But you can pick when.
right.
You can pick one. Nate, we're playing a little fast and loose here. My informal definition of the limit gets us in trouble here, and you have to take a more advanced math class to answer it. But basically, this doesn't reach 0 until you let it. So this is going to seem like such cheating to you. I'm not dividing 0 by 0 here. I'm dividing something very small by something very small before it gets to 0.
But then why don't you add something very small to the end of that?
We don't have to is the short answer. That's a great question that we're not going to cover today. All right, I'll try and talk about that later.
Well,
But,
okay, no, so
But no, we can't. We got too much to do. Okay. All right, but I like that question. So here's what we just figured out. What a limit really is complicated. I'm giving you guys a short working definition that honestly will get you through high school, and really probably the first year or so of college. If you go on beyond that, there's entire courses on this stuff.
On limits. Functions that have to deal with limits.
More the second, I think. Okay, so what we started with was f of x equals x squared, and we got f prime of x to equal 2x. What this means is, if we're looking at a parabola, you can ask me about any point on the parabola, and I can tell you the exact slope of a line that barely touches the parabola at that point. Okay? And we talked yesterday about the specific applications of that. Remy and Danny and I talked about a punch yesterday, and how hard a punch actually hits someone right at the point of contact. Not what its average speed was along the path to somebody's face, but what it actually, the instantaneous speed of the punch at the moment it collided. And, but any questions on what I did here algebraically?
Could you use, if you knew what delta x equals, could you use, and you knew where the points were, could you use that to find the length of the secant?
Yes.
Would that help you
Well,
with
that'd be the distance formula would be the easiest way to do that.
Or you could use